Yeah, thanks very much for your introduction, and hello everyone. I'm quite impressed by your activities lately. So you've gone down to 43 blockers overall. It's pretty amazing. So maybe the 0 will be reached by the end of this work week. So it's really impressive. I'm happy that I'm here, and I hope you will enjoy a little short talk about this topic. It's an interesting link that I'm trying to make, because indeed, if any of you is aware of what quality of experience is, then it may not be so evident what that has to do with Firefox OS. And I'm trying to indicate to you what the link is that we're trying to establish and currently looking at. Okay, so this guy is, of course, a guy who's looking mainly on the network. So he's investigating the network, and so media in our context, the context of my group. I'm heading a small research group here at TU Berlin, and I'm affiliated to Deutsche Telekom within the T-Labs, Telecom Innovation Labs. And we're looking at mediated, so media QE, in terms of media that is transmitted across networks. So anything which is transmitted over IP, like audio, speech, or just simple web pages, in terms of how users perceive that when there is such a network in between. That's something we're interested in. And we're trying to build models which automatically predict how satisfied a user is with such interactions with such services, right? So we want to help operators by getting them models, or giving them models, and also, of course, manufacturers, so that they can optimize their services by not only looking at technical parameters, but directly feeding such technical parameters into a model which will automatically generate some prediction of how the user will ultimately perceive the service, right? And that's shown here. So let's pretend we have some web apps, or we have media streaming, or any kind of communication links. So we're also looking into conferencing or classical voice over IP connections and so forth. And then you have some kind of transmission, and then you have the user, where we're interested in knowing what the quality perception of that user is, right? And what you typically do, you use models. So what you do, you either analyze the stream itself by, for example, analyzing packet headers. That's a classical thing which is done in monitoring of voice over IP, for example, or of IPTV services. Or you directly look at the signal and try to analyze certain signal features. So it's then actually more a signal processing task. What you're trying to do is to rebuild some features of the user, and that can be actually low-level signal processing. It can be a bit more high-level things like what's short-term memory things. You could use some Markov chains therein in order to simulate certain user aspects. Or you could really try and go up to the cognitive layer and try to really have a cognitive model which reflects even the expectation a user has, maybe with a certain context or also media application. And what you want is to predict exactly what the user actually perceives, so the satisfaction level in quotation marks. You want to predict that with this model based on this information that I'm briefly sketching here. Okay, and what is quality of experience? There has been long debates about this. There's a recent definition from some kind of a European cost project where we have actually tried to define this. There's a white paper out there which you can easily look at. It's actually from this Qualinet webpage. So if you're interested in this QE stuff, it gives you a nice kickstart in terms of any kind of definitions. And maybe don't read it, I just tell it to you verbally. So what it is you have some kind of media interaction, and you as a user, you have some expectation based on a certain context you're in, and based on the level of satisfaction and annoyance, right, you will have a certain, or in terms of annoyance or satisfaction, you have a certain experience with that usage, right? And that, of course, directly applies to any usage of a device like a Firefox OS device as well. But, of course, there's a very thin line between what we typically describe as UX and QE, right? I mean, these two terms are somehow overlapping, and I'm not trying to solve this problem today, but obviously QE and UX are somehow tied together when you think about it like that. Okay, and this is what the typical service provider as Deutsche Telekom typically likes to have indicated. The fact is that you have certain knobs, and it's the same here with all of you guys sitting in this room. You have certain building knobs in the OS which you're turning right now in order to reduce the number of blockers. And of course, in the end, these building knobs are somehow connected with something the user will perceive on the perceptual side when he uses this OS, right? I mean, he will be annoyed when something is not working, or he will be annoyed when something is not as smooth as he may want it, or he may be super delighted because you have made such great design choices, right? So it's this the attempt of differentiating the building knobs, the technical building knobs you have on the one hand side, and the features which the user perceives on the other hand side. And that's actually what is typically referred to as quality of service in the telecommunication domain, and quality of experience, the feature side in this quality of experience research. And what we do here at T-Labs, we have an approach which we refer to as quality engineering. And why quality engineering? It's because we're looking at certain applications, we're conducting research, and then we're trying to standardize the research that we have done or the results that we have achieved, right? And why standardize? I will go into details of what we mean by standardization. But standardization in this sense means we define some guidelines and rules so that these applications get better. Right? So that's the main goal, make these applications better. But at the same time, obviously, if you have such a quality model or any kind of user experience model in place, you can consider the application of that model in any kind of optimization context as an application per se. So meaning you have now a double meaning of this word, application, obviously. And what you get out of this work is, of course, some simulations and systems, some test methods. So subjective test methods is a very big point as well, right? And you have databases, of course, models, service recommendations, and such standards. And why am I saying standards? So why am I so keen on highlighting these quotation marks? One of the scales typically used in such work is this so-called MOS scale, MOS scale. I am pretty sure that most of you have heard of it. It's like this school grade kind of scale. I mean, depending on what, how you look at it. But it's typically this 5-point scale, and typically, especially when it comes to speech quality and video quality, these terms are, or these quantities are typically quantified in terms of MOS, right? And the big problem with this scale is that typically people treat it as if it was centimeters or meters or any kind of SI type, well-defined, scale. But it's evident if you have a wideband speech connection, right? And you have a test where users would rate a certain wideband speech connection almost 5, right? So very good. And at the same time, you have a different test where you only test in the same test narrowband connections, so having a reduced bandwidth of the speech signal. People may also just rate 5. And now you get to the operator, and the operator says, well, why should I adopt wideband speech? HD voice, it's completely useless because the MOS rating is the same. But wait a second, the MOS rating is only the same because you have measured in 2 different contexts, right? Because it's not a centimeter scale, obviously, such quality scales. And that's why you need standardization. So you want to have a fixed relation between such quality evaluations on a joint scale, ideally, right? You want to really be able to translate them, to make them understandable to everyone, so that you don't have to do all the tests again from scratch, including all possible conditions, but you can go and have the knowledge of, I'm using such a method in a certain context, but knowing the transformation rules, I can actually translate it to yet another context. Okay, so that's the idea. And of course, this means you need a precise measurement and very well done specifications. That's what you actually know for those of you who work in the UX Gaia kind of team. Here, you were aware of the fact that you have to well document any kind of user interaction research. And this is really something which we're trying to promote here is this reproducible science as well, right? I mean, the better you have described a certain experiment, the more easily somebody else could repeat it. And then, of course, it's much better understandable how certain ratings on certain scales have been obtained. And there's actually the real standardization which you could do, and that's what we're trying as well, especially in this telecommunication field. It's quite important to basically promote such methods to standards so that people can just take the standard out of the shelf, even if they are not really experienced with such methods, and basically get similar results. Okay, and now I want to give you a few examples of applications, and then of course come to why do we look at this here for Firefox OS a little bit. So let's pretend again we have this framework that you have already seen. There are actually 2 types of main models. One of them are the so-called signal-based models, right? The full reference models. That's something anybody who works a little bit on video or so may have heard about those. What you do is you compare the output signal of any kind of transmission with the input signal of the transmission, right? And then you can do some kind of perceptual modeling where you really represent the perceptual processing that occurs in the head of the user in order to map that to some kind of quality quality scale, right? So it's really very perception-oriented. It can be also as simple as the PSNR. I mean, who of you has heard of the PSNR, the peak signal-to-noise ratio, which is to be used for video quality? Okay, I see. No problem. But anyways, that's a very crude kind of measure which only basically compares the two different signals in terms of what is the added noise that a certain processing such as video coding, H.264 or MPEG-2 or whatsoever has introduced there. Okay, then another type of models, and that's the one that we're mainly focusing on, and which is also mostly interesting, I would say, for Firefox OS evaluation, is any kind of parametric models, where you actually find a means of describing the problem space in a parametric fashion, and then you have some kind of rule set, right, which translates this parametric description of your technical case, so the QS side, into some kind of quality evaluation or user experience evaluation that applies in the same way there. And the good thing about this is you get direct diagnostic information, right? So you know exactly when there's a problem with quality. If your model works well, yeah, right? You see that there may be a problem with quality. You directly know why there is a problem with quality. Because you could now argue, why don't we just stick to individual parameters and use thresholds? You could do that, but the problem is you have many times interactions between parameters, right? And so this may lead you, if you do a purely threshold-based method, especially when it comes to media signals or complex tasks, this may lead you to either over-engineering your device, right, or your network, or it may lead you to completely under-engineering it because you have left out some negative interactions between certain degradations. Okay, here's an example. Just quickly show you a little video, but it's really short. It's just to indicate to you the problems that are typically occurring in IPTV. It's a very strong one in this case, so it's a typical slicing degradation, right? You see that there has been packet loss on UDP transmitted video. Of course, we don't have that in TCP transmitted video, but it's just an example, right? So this is a typical degradation, which indeed, not to that extent, of course, because of the great network quality, but which may indeed occur in IPTV solutions, even the one by Deutsche Telekom. And so what you have in that case, right, you have these spatial degradations here, and with such a parametric approach, this is a multi-layered model which we have developed, and some of the components, some of the layers have now been accepted as standards by ITUT, so you can actually use them. You can go to the internet, take the standard, and basically implement it and use it for video quality prediction when it is transmitted over IP MPEG-2 transport streams. So it basically takes the network stream and translates and extracts certain packet header information, which we even translate into frame layer, so video frame layer information, right? So based on packet header inspection, only packet header, so it works with encrypted streams. We can get information about the complexity of the video, for example, right? Because of some nice tweaks we have come up with there. And this, for example, is then used as shown here, right? So you have these errors here, which are more or less visible, and then you have some kind of binary error map, which you can calculate. And you can calculate such an error map even just starting from packet headers. Or you can go further, and you look really into the packets, so into the payload, and you do some kind of error estimation really in terms of how bad is the error visible, right, and so forth. And these are then some kind of parametric description of this type is then mapped to quality, and this would reflect any of these two layers here. Okay, then the next one, and that's the classical one you're probably all very familiar with, is you're watching any kind of YouTube session, right? And then there's some kind of a network problem. YouTube has also changed their policy of streaming lately, and for my taste, not always to the good. Because really, you very often see this, right? I mean, the stopper indicating to you, or some kind of loading bar that you have to wait a little bit because it's not yet loading. And this is what we typically refer to as rebuffering or stalling, right? So these stalling events are really annoying because you're basically in the video flow and then all of a sudden it hangs and you don't see the continuation, right? You could accommodate that by appropriately preloading the video, right, to already have something on the device so that the buffer is not running empty. But yeah, anyways, it doesn't really help the problem. So this is a very important degradation. And there we already get a little bit closer to what we are trying to do with, or for analyzing Firefox OS a little bit from the telecom perspective or from the T-Labs perspective. And that is looking really at this waiting time. Oh yeah, thanks. Yeah, and here's an example where basically this MOS rating is compared to the number of stalling events that may occur in video clips, right? And this is for 30-second-long YouTube video clips. It was based on a crowdsourcing study that has been done by our colleague Tobias Hosfeld. And basically what you can see is it's, of course, the number of stalling events, which has a lot to do with how you perceive the quality of that YouTube session, but it's also the length of each individual loss. Right? It's pretty evident, but it's actually quite nice to have such curves, because then you can decide what's the best streaming strategy. I mean, how can you best adjust the buffer in such a way that you achieve the best possible point on those curves, assuming you have a certain bitrate available, right, or bandwidth, channel bandwidth available. You want to stream a certain video bitrate. Yeah, that's pretty obvious. For those of you who have to do a little bit with video, you may have heard that there's this current activity which is called DASH, the Dynamic Adaptive Streaming over HTTP, which is a bit more advanced because it adjusts the choice, the selection of the bitrate that is taken from the server according to the bandwidth resources or the bandwidth capacity of the channel, right? And that avoids the stalling, because the stalling is really the main problem in video quality nowadays. And if you have a slightly worse bitrate for some seconds, it doesn't affect you as much as when really the picture freezes and you have to wait until it's reloaded, right? Okay, now this can be translated, this waiting can be translated to web pages as well. So let's pretend we have a web page loading. It's a very simple web page I'm simulating here, right? It's actually my colleague Dominik Strohmeyer who has done this. So let's pretend this web page is loading, right? Depending on what you're interested in when you're having a certain web browsing session, you may be more or less annoyed by the way in which the page is loaded, right? So if you are, for example, very interested in a certain part of the web page and that is loaded as last, it's obvious that you will be most annoyed if by coincidence what you're interested in is appearing first and you can directly click on it, assuming that the browser is actually accepting that click already and is not waiting until the page is fully loaded before it processes the click and so forth, then you may be less annoyed. And interestingly, what we have found is, at least for desktop-based research, when you have a free exploration, so you're just surfing the web, you're just wanting to retrieve some information therein, versus you have a certain task in mind, you really want to know something in the web, right? There is actually a different preference for either this continuous loading, as for example, Opera, the mobile Opera does, or some other browsers do, that basically you have that's the blank loading, so that you basically wait until everything is in the cache and then you display it, versus you have different elements of the page being loaded continuously, right? And interestingly, if you have the free exploration, so where you just want to surf a page, it seems to be preferred to really have this blank loading, so have a certain waiting time until the full page appears, because you actually don't really know what you want to look at that page. However, if you have a real task in mind, you really want to do something with the page, you're searching for a certain element on the page, then it's absolutely evident that if you somehow know what the user now wants to do on the page, you will have an advantage of basically loading that element first. And I'm pretty sure that browser developers, and it would be nice to discuss with Mozilla about this, already have some of those features in place. But what we are trying to do here is really build models which would directly be predicting which loading pattern would be the best one for you, right? Okay, and now the link with Firefox OS is obvious. I mean, we have had a few discussions, so anything which I have written here is basically based on the discussions my colleagues had with you guys, basically, and especially also the kind colleagues of Mozilla and their UX team. So what are the UX or quality aspects that you're looking at? So it's on the one hand side, it's the user perceived performance, obviously. So you have app or web loading times. Then you have there are some workarounds. You can do some kind of lazy quotation marks, lazy loading in the background. Then of course it's the interactivity as such. So is scrolling smooth? Is when you have loaded an app where you have some kind of text field where you want to put input into, is that responding to your fingertip soon, or do you have to press 100 times before it finally actually accepts you to type in something and so forth? I mean, those are issues which we are all aware of. Then there have been numbers mentioned by some of the Mozilla colleagues, and I would be happy to maybe discuss and maybe get some documentation about this, that the overall goal would be to get down to 50 milliseconds reaction times and 60 frames per second. Would be very interesting for us to know where you are right now with those. And then, of course, you can keep important applications in the background and have them easily be loadable, right, when you can somehow foresee already that the user wants to use them and so forth. And then there are some workarounds that you have already implemented. So you can accommodate or can compensate for waiting times by, of course, doing some smart transitions, having some graphical information being displayed. So there are lots of ways of doing this. And for us, it would be extremely interesting in either knowing what kind of rule sets you have for that already. We would like to really get into this. Or if there are not such really, systematic rule sets, maybe, I don't know. Then it would be, we would be very happy to develop those together with you, of course, after the launch of the first version is out. And our simple assumption is basically you have some time component which is due to the hardware for any kind of interaction of the user with the device. Then you have a certain time which is related with the OS, which is of course dependent on the hardware in some way, so it's not completely orthogonal, these two. And then you have some additional time which is basically linked with the app and in the way in which the app is implemented. And of course, again, that is dependent on the OS and on the hardware and so forth, so the API. And then basically the overall interaction time, let's say, is somehow some kind of sum probably of those three. And then we assume that the user experience or quality of experience that you have when you're talking about how responsive is your device and how smoothly is your operation with it, that this is somehow a function of this time, right? It's a pretty simple approach and assumption, but we believe that is probably more or less true. And now some research questions which I would like to think about, but maybe they're all solved, then it would be interesting to learn that from you. So what's the minimum of these hardware and OS related times, right? And is the minimum that you achieve currently with your current version or with any combination of hardware plus version that you will achieve in the midterm, will that be below perception threshold? And if not, I mean, if it's not below perception threshold, then it would be interesting to have some kind of, to work with any one of you who is interested in that to get some kind of model in place, to maybe have some rule set, okay, if it's that type of interaction, you want to have it be this and that fast and so on. But I assume there's already lots known to you, mostly probably expert knowledge. And of course, an interesting point would be what would be the respective instrumentation of Firefox OS, and we have spoken with a few persons in this room, and there seem to be ways to maybe monitor basically behavior of user, predict basically where on the screen which element occurs or appears, and so forth. Okay, and then I misspelled Poland. I'm really sorry for that. It's an accident. Anyways, so other things which DT would be interested in is basically adopting some of the user experience tests that have been done in Brazil by Mozilla and things which have been done by Telefonica and maybe also together to maybe adopt them and apply them in Poland, or think about whether it makes sense to do it also there. Are there any differences to be expected? Does that make sense? Then, of course, some contribution to the workflow and use case documentation for UX or QE, as depending on how you define it. Then, of course, we are already now doing some expert review in the sense that we are, without having the background of having used Firefox OS already hundreds of times, we're actually trying it out and noting bugs and then checking with you guys whether those bugs are already available and so on. And then, of course, it would be interesting for us to think about, especially when it comes to add-ons for operators like Deutsche Telekom or Telefonica, are there any guidelines for such add-ons? What should you do in order to ensure that there are no user experience issues which are related with this? And really, for us, for our group, it would be most interesting, and of course, we can really say something about that when it comes to anything which has to do with these delays and interactivity with devices. Okay. That's it. Thanks for your attention. It was a bit longer than 15 minutes, but I think that I had some attention. That's great. Then I wish you a great finish of this work week. And of course, if you have like one or two quick questions, then I'm happy to answer those.